So this was a weekly pop quiz 8. In question number 1, students prepare a sample of insoluble salt, which is lead to chloride, I mean, by mixing aqueous solution of the two salts in a beaker. So lead to chloride, yeah. So lead to chloride is insoluble salt. So whenever we want to prepare an insoluble salt, we mix the two soluble salt. So we need lead and we need chloride. Like in one of the salt, we need lead, and another salt, we need chloride. So because all nitrates are soluble, so what will be the first salt? The first salt will be lead nitrate. And what about the element present in the second salt? Because it is a chloride, so group 1 salts are soluble, so we prefer to use any group 1. Like example, we can mention sodium chloride. So when we mix lead nitrate or lead 2 nitrate with sodium chloride, it will form lead chloride, and that will be the insoluble salt. So whenever you want insoluble salt, whenever you need insoluble salt, you separate the name of the insoluble salt. The first name is always with the nitrate, and the second name is always with the group 1 element. You can mention lithium, sodium, potassium, any group 1 element you can mention. Then write an ionic equation for formation of the lead 2 chloride. So we want to produce this lead 2 chloride or PbCl2. So if we want to produce this lead 2 chloride, what are the ions present?
Pb2 plus and Cl minus.
So we need lead Pb, which is 2 plus, and we need chloride ion, which is minus, but how many of them? We need 2 of them. Include a state symbol. What are the state symbols? Ions are aqueous, so lead is aqueous. Chloride is also aqueous, and because insoluble salt, lead chloride, which is solid. List the steps the student should take to prepare a pure sample of a lead 2 chloride from the mixture in the beaker. Like student has mixed two salts, two soluble salt. When he mixed them together, as a result, it produced an insoluble salt. So this insoluble salt is lead 2 chloride. The question is how we can obtain, like list steps the student should take in preparing a pure sample of a lead 2 chloride. So first what he should do? He should filter. Filter to remove the insoluble lead 2 chloride. Then he should wash with the distilled water, and then he should dry with a tissue paper or a filter paper. So the insoluble salt is prepared by mixing the two soluble salts. So as a result, when we have an insoluble salt, we just filter it first. That will be the residue. Yes.
Filter wash, will we get the mark or
You will show the mark, but I'm writing a keyword here for the answer. Like even if you write filter, wash, and dry, you will score the marks. But try to elaborate. Try to explain what how you will filter, how you will wash. You will mention filter by using a filter funnel. Even in the marking scheme, they don't write the full answer. They write the keywords only.
they came for the keyword.
Yeah. But you should try to, when you as a student, you should try to write the answer. Next is student carries out electrolysis experiment on the molten lead 2 chloride. Using an apparatus, the chlorine gas is formed at anode and escape from the apparatus. Explain why lead 2 chloride need to be molten before it is conducting electricity. Why we not need a molten? Because it's an ionic compound. Yes. Anyone want to say answer? Yes.
There would be free ions.
To separate the
Yeah, in
to break
molten
those
state, ions will be
bonds.
free to move. In a molten state, when ionic compound in a molten state, the ions are free to move. So when the ions are free to move, it can conduct electricity, but ionic compound in a solid state, it cannot. Next is write ionic half equation for a reaction at anode. So what are the ions present?
Discussing what is
And-
so we also wear one. Sorry, protects the eyes. Protects the eyes and wear one. It looks beautiful on you. And something else.
So we have a positive and a negative. The lead ion will move towards the cathode, the negative. And the chloride ions are negative, so they are attracted towards anode. So what will the equation at anode? The chloride ions,
Yeah.
when two chloride ions are there, they will form a chlorine gas and it will lose two electrons. So 2Cl gives Cl2, the chlorine gas, and two electrons will be there. Because in molten state, the electron, if you mention molten state, electrons are free to move, that will not score the mark. You have to use, give him space. You have to use the term ions are free to move. This is the past paper, pop quiz 8.
Sir, you sent something in physics about 23 pages.
That was ionic half equation.
I forgot to write it, sir.
In ionic the state symbols ions are always aqueous and insoluble substances are always solid. So we need ionic half equation for a reaction that occur at anode. So anode is a positive terminal, cathode is a negative. And it's a molten lead 2 chloride. So there is a lead ion and there's a chloride ion. Chloride ions are attracted towards anode and the lead ions are attracted towards cathode. So what is the equation? Chlorine is -1. It will be -E, form a chlorine atom. But because chlorine is a non-metal and non-metal can exist as a molecule, so when two chloride ions are there, they will lose two electrons and it will form a chlorine gas. Or this electrons you can write in the product side because it is negative, the other side will be positive. So it will be two chloride ions gives a chlorine gas plus 2E. So both equations are correct. Usually in exam, they write the equations like if it's a loss of electron, they write the electrons on the right hand side. If it's a gain of electron, they write electron on the left hand side.
So what is the mark distribution?
Sir, molten lead is PP2.
Molten lead 2 chloride is PbCl2. Yes.
Can you repeat the part?
1 mark is for balancing, 1 mark is for the product.
Sir, can you tell the answer for part one?
Ions are free to move in a molten state. State the test for the chlorine gas. How we can test the chlorine gas?
We can hold that litmus paper and gas
Yeah.
and paper.
Damn
turns
litmus
red,
paper
then-
turns from red to blue.
But which damn litmus? Red or blue?
Red.
Red.
Damn blue.
Why, sir?
Or will you use
Because
mark-
chlorine, when it dissolves in water, the solution will turn acidic. That's why when we take a damn blue litmus, first it will turn red and then it bleaches.
Sir, will you lose mark if we don't write the color in that?
Damn litmus paper is also fine, but blue is the right term. So damn blue litmus and observation, it bleaches. Bleaches means the color will be removed. So it should be,
Then
hmm?
it will be turned red then blue.
Yes. If you actually, first it will turn red and then bleaches. That is what practically happened. But if you want to write the final result, you'll mention it bleaches. Describe what is observed at cathode.
Molten lead is formed.
A solid forming,
Uh,
solid depositing.
The solid deposit.
Yeah, solid deposit. You cannot say a lead is formed because by looking, whenever your observation is there, you're not supposed to write a name of a compound. You can mention shiny solid. Whenever a molten ionic compound is there, what is the observation at the cathode? It is always a shiny solid, irrespective of what compound. Even molten lead 2 chloride, molten sodium chloride, any ionic compound, molten state, it will be a shiny solid. No, it does not make sense. Like example, in chemistry, by looking at a substance, you cannot say this is lead, this is silver. Like that's why whenever a question is there about observation, you're not supposed to say the name of chemical. You have to say like what you will see rather than then if they say what you conclude from this observation, then you can say yes, we conclude that it is chlorine is there, lead is there from the
So
observation.
you will lose mark if you say molten lead.
Yeah, you will lose the mark.
There's a formula for this is PbCl2.
Yeah.
So
Let-
the white ferrite and the next example for another 2Cl, like Cl2 plus 2E minus.
Because the ions will move. It contain a lead ion and it contain a chloride ion. If we don't bother about how many chloride ions are there, we first write equation for one. Like maybe let's say it was molten aluminum chloride, AlCl3, but we don't write equation for 3 chloride. We always write for 2. Irrespective of how many chloride don't bother about the formula of a compound. Just identify which ion is there. Maybe there are 2 chloride, 3 chloride, maybe 1 chloride ion also, but you always write equation for 2. Question 2. Chemical reaction involve the transfer of thermal energy. State the term used for a transfer of thermal energy during a reaction. So yeah, good. Enthalpy change, or we can also say energy change. Enthalpy change is a standard term. Energy, this was pop with it. Yeah. Energy change, or you mention enthalpy change. Both will work, okay? Tetrachloromethane, which is CCl4, react with steam as shown. This is a reversible reaction because the arrows, how you identify, it's a reversible reaction, arrows pointing both ways. Reactant is forming a product is forming back the reactant. The forward reaction is exothermic. If the forward reaction is exothermic, what it prefer for a product? High temperature or low temperature? So it prefer a low temperature for a It prefer a low temperature for a higher yield. Like we want more product, then we should decrease the temperature. State what happen, if anything, to the rate of a forward reaction if the concentration of CCl4 is increased. Explain your answer in terms of the collision theory. What is a collision theory? Collision theory state that if we have more collisions of the particle, the faster the rate of the reaction. That is the collision theory. So if we increase the concentration,
Rate of reaction will increase.
so if we increase the
More particles
concentration,
collide with
what will happen to the collision? Number of the collision?
increase.
More frequent collisions.
Number of collision
Number of
increases or the
collisions
frequency,
will increase.
or when number of the collision per unit volume, we will say it will increase. So as a result, what will happen? The rate will increase, or rate of forward. So increasing a concentration means there will be more collision of the particles in a unit volume. As a result, the rate of a reaction or the forward reaction will increase. Yes? What?
Says thermal decomposition exothermic or
Thermal decomposition is endothermic.
endothermic.
Electrolysis is also endothermic. We provide energy.
Okay.
State what happened to the position of equilibrium when the pressure is increased. Increasing a pressure shift the equilibrium towards side of less moles. How many moles of a gas here? 1 and plus 2. Total 3. How many moles of a gas? 1 plus 4. Makes 5. So if I increase the pressure, increasing a pressure shift the equilibrium towards side of less moles. So which side it will shift? It will shift left. Yeah, so here they ask us, state what happened to the position of equilibrium. We'll mention shifted left
Less moles of that.
and increase in pressure. shift the equilibrium towards side of less moles and the reactant has less moles.
Then why does it shift it to the left side?
Because you have, it depends on the number of collision. What you did, you have, let's say you have a container, okay? You have, in the question, you have three molecules of the reactant, and you have 5 molecules of the product, and you're compressing them. So when you compress, which one will have a greater chance of colliding? The reactant or the product? The product. Because the product molecules are more. So as the number of chance of collision product has increased, as a result, the reactant will form more. Because like more particles of a product are there and you compress both reactant and product. But because the product proportion was higher, as a result, the product molecules will collide often and they will form back the reactant. That's why increasing a pressure always shift the equilibrium towards side of less moles. Next is figure 5.1 shows an incomplete reaction pathway for a diagram. On a figure, insert a formula for the reactant. So we have to insert a formula for the reactant. So the reactants are CCl4 and we have H2O.
And do we have to include it?
And the product, state symbol is given, so you can directly add. It's already given. If you don't add, I don't think you will lose mark because insert a formula, like just a formula, not the state symbol. Draw an arrow for the activation energy from a reactant till the start of a reaction, that is activation, we call EA, and enthalpy change or transfer of energy from reactant till the product, that will be delta H. The next is define the term activation energy. The minimum, you have to use the term minimum. It's a minimum possible energy to start the reaction. Okay. Minimum is important, like minimum possible energy which we need to start, and then to start a reaction or energy at which the reaction start, that will be the second one. State one way in which the activation energy can be changed. Activation energy can only be changed by catalyst. So by use of the catalyst lower the activation energy without chemically change. Enzymes are biological catalysts. If it was a biological reaction like respiration, then you will mention enzyme. But here, it's not a biological, like it's a tetrachloromethane is there, which is reacting with water. So you cannot say enzyme. You will lose a mark in that case. The next is, you have to calculate, the equation is there, calculate the energy to break the bond, energy release when the bonds in a carbon dioxide form, and then calculate the HCl. Bond energy. So first, calculate the energy needed to break the bonds in the reactant. So we have how many bonds? 1, 2, 3, 4 CCl bonds are there. So this will be 340. 340 multiplied by 4. Plus, there are OH bonds are there. 1, 2, 3, 4. So 4 multiplied by the OH bond energy or HO bond energy is 460. What's the answer here?
3,000.
3,200 kilojoules. Okay. The next is calculate the energy released when the bonds in the carbon dioxide form. So when the bonds in the carbon dioxide form, like for a carbon-carbon double bond, this is 1 and 2. So this will be 805, but how many of them? 2 of them.
2,170.
805 times 2.
Uh,
1610 it will be.
1,610 for 805.
Yeah. Now we have to calculate the HCl bond energy. So we use a formula. We'll use a formula that the bond breaking energy minus the bond forming energy is equals to energy change. Okay? Or energy change is bond breaking minus bond forming. The bond breaking energy is this value. So you write 3,200. Minus the bond forming energy, this total is 1610. What about HCl? How many of them? 1, 2, 3, 4. So how many are there? So if 1 is X, so how many total will be there? It will be 4X. So if 1 is X, so the total bond forming energy will be 1610 plus 4X. And that is equals to enthalpy change, which is given minus 130. Now we solve a mathematical equation. So we have 3,200 plus minus minus 1610 plus minus minus 4x, and then it is equals to minus 130. What is the answer? 3,200 minus 1,610.
1,590.
1,590 minus 4x is equals to minus 130. This will move other side.
X is equal to 365.
Minus 4x is equals to minus 130 minus 1590. Minus 1590, actually add them. 1720 negative. So minus 4x is this, negative, just we divide. Yeah, so we just simply divide. So x is equals to minus 1720 divided by minus 4. What's the answer? 365? So 365 kilojoule per mole.
Sorry.
What?
430, sorry.
How much?
430.
430?
Yes.
430.
Yeah,
430 kilojoule per mole. So whenever you need any bond energy, if the reaction was endothermic, the enthalpy change will be positive, but the reaction is exothermic, so energy change is negative.
AC?
Heater.
You have a soft spot.
No.
Yes,
I
yes.
have a brown skin.
Yes.
This was a pop quiz 8.
Then it's better to